Ladies and gentlemen, please welcome to the stage Naomi Price, Conference Director for Designcon.
Thank you, and welcome everyone to our final keynote of Designcon 2021. Before we begin today's keynote, a few reminders about health and safety at the event. By county mandate, masks are required while indoors at Designcon. If you do not have a mask or need a replacement mask, please visit our information desk in 220B for a complimentary face covering. Outdoor spaces are available for small meetings. Outdoor areas do not require a mask. Hand sanitizing stations are readily available throughout the venue for your use. If attending a session, please do exit the room promptly at the session's end. This will allow us time for our increased cleaning between sessions. And please watch the app for any updates. Our expo hall opens after this morning's keynote. Be sure to visit the more than 80 suppliers and stick around because at 5 p.m. our booth bar crawl begins. Offering complimentary beverages and bites to all attendees, exhibitors, speakers, and committee members. We hope you enjoy this last day of Designcon 2021. Know that your education, networking, and sourcing doesn't have to end today. Be sure to mark your calendars for Designcon Digital, our first virtual event, October 5th to the 6th. Can you roll back a little bit, please? Thank you. Where we will host additional educational sessions and exhibitors, and make plans for Designcon 2022, April 5th to the 7th, 2022. Watch designcon.com for more information on both Designcon Digital and Designcon 2022 when we return to Santa Clara. Now let's begin today's keynote. The development of autonomous and automated trucks, cars, trains, and delivery bots has been exciting to watch, particularly the development of the advanced sensing technology needed for these moving machines to intelligently navigate. We have arranged a truly exciting keynote for you today. Indu Vijayan, the Director of Product Management for ADAS Solutions at AEye, will discuss AI-driven sensing and take us through a real-time, interactive driving demo to show how that technology is helping vehicles see smarter, respond faster, and accelerate the adoption of autonomous features. And I did get a little note that I wanted to share with you. AEye actually began trading on NASDAQ today under the trade name Lidar, L-I-D-R. So I think that's pretty exciting, especially since it coincides with Designcon and her keynote. Please join me in welcoming Indu to the Designcon keynote stage.
Hello everyone, it's a pleasure to be here in a live conference after, I don't know, such a long time. It's so exciting to be here. And just to give you an idea of what I'll be going through is about autonomous vehicles in general, how the market trends are moving at this point for autonomous vehicles, how sensing is moving with respect to that, how technology has grown. And also, almost towards the end of the slides, you will see a live demo from Dublin, California as well. So that's the most exciting part of this keynote here. And just to give you a background of what I do at AEye, and my generic background before that, I currently have the title of Director of Product Management for ADAS Solutions. What does that mean, right? I work with our tier ones. So tier ones are generally system integrators for OEMs like Mercedes-Benz, BMW, GM, Ford, etc. So I work with them to make sure we can take our unique architecture and design and make it production-worthy, scalable, and reliable in the way automotive works today. That is, for 15 years, the lifetime of the car, LiDARs to work efficiently and reliably. I also previously worked at Aptiv, which was then called Delphi, and there I've been working with sensing technologies for L2, or say all the AEB, all these sensing capabilities that you have on the cars today, which you drive around. So I picked up a lot of things from there and saw what AI has, and that intrigued me. So that's where I am today. Another thing which I passionately believe in is VIA, Women in Autonomy, which is a forum for women to come together, equip, and empower themselves, and also to make sure we have our voices led. And it's not just women, everybody be there together so that the voices are heard, especially in this next generation in the automotive space. And to bring that voice together so we go forward with the right decision being made for autonomous driving capabilities. All right, you might wonder why this picture. This is a picture from Futurama in 1939, where people envisioned the future of how the future would be with automated driving cars, with big skyscrapers, etc. To think that this was a dream so long back, and in 1959, there was this idea there that you see here, where cars would just move forward, get onto a highway, push a button, and it'll start driving on its own. And this was something GM and RCA tried to showcase in that futuristic show space. So it's pretty interesting how so long back people have envisioned this, and this has been kind of interest for a lot of people at that time. And then when we look at it today, these kind of interests and having like DARPA challenges where autonomous driving vehicles from different universities actually showcase in around 2005 that they can actually drive automated in a car race. This led to many people thinking about starting it commercially. And many other factors, like for example, the OEM saw this as a unique opportunity to sell these features with the up price of, like, say, around $5,000 to $10,000 on their cars. And this started to disrupt how the OEM started to think about software as such and the sensing capabilities. You can see that how from 1959, where cruise control came into picture with no sensing, just driving straight on the road, and how this spirit around autonomous driving, and also the fact that we can have these autonomous driving features add to our business models and increase revenue, led to having collision warning system and adaptive cruise control, and all that's leading towards now we talk about highway pilot in 2021, where you expect cars to drive automated on the highways, which is very interesting in the whole lifespan of automated driving as such. There is another factor that actually led to this also. There's an increasing number of deaths, even in 2020, when there was a pandemic hit. 30,000 people was reported to be dead due to casualties on the road, which is kind of intriguing when even the miles driven was 13% less than general. So all of these factors led to having safety standards on cars and having more sensors to assist people when they're driving, when they're either drunk or just sleepy while they're driving on long drives, etc., as we go. The another thing, when I'm talking so much about, okay, we need automation, there is different levels of automation. In order to start, we start from zero, and in order to reach the higher levels of autonomy, there are various steps towards it. So I'm assuming many people have already seen this. This is the SAE levels of automation. And as you all know, level 0 means there's no automation. And many people have on cars driver assistance systems, like where the blind spot systems blink on the side if there's people driving next to you, etc. So these are already available. And there is already ACC kind of features where you can take your feet off the pedal. And this is the state where we are right now, with more of the cars being more enabling you to do stuff more than just driving while you're either commuting from your office to your home or going for a long drive with your family. What we are trying to do today in the autonomous driving space for, say, in next 4 years to 5 years is try to achieve somewhere in between level 2 and 3 conditional automation. The idea there is, can we get the hands off also, that is from the steering wheel, so you can maybe take some rest, talk to your child in the back, and while the car is driving, but the expectation is that the car would give you an indication to come back to driving. Beyond that, there's high automation, especially in geofence areas, because the last 5% to get to full autonomy is a big challenge. And even though the technology is possibly there, there's multiple other factors. For example, unprotected left turn. All of these are scenes which we still need to completely understand and solve, and also regulations, et cetera, that contribute to it. This is a busy chart here, but the main thing I wanted to talk about is this is a chart from YOL development. And with such a uptick in having automated driving features, you've seen the last decade, traditional OEMs like Mercedes-Benz, Daimler, BMW, or anybody has changed the way they market themselves. They all are turning towards services model or subscription-based model. You've already seen Tesla go into software-driven subscription models, and there's a huge upsell in the software. You've also seen that in Super Cruise, for example, from GM, there's a 90% take rate for it. People love having automated driving features. Even actually, one of the polls we did at AEye, 53% of the people who engaged in the poll would like to have highway pilot on their cars, on the next cars. So it's very interesting how all of these market demand has led to seeing more level 2 and beyond, that is conditional automation, and moving towards level 5 going forward. So we expect that according to YOL development, by 2035, we expect to have a quarter of the global cars to be L3 and beyond, and the rest of it going to be L2+. So that's a very interesting place to think about, that most of the cars you see on the road is going to have some level of automation. And as these OEMs and are going towards more of these capabilities in the cars, and ADAS is taking off. ADAS being assistance systems, right? All level 1, level 2 capabilities. They have a huge uptick right now. And also with the safety mandates coming in, you will see NHTSA adding safety mandates. Euro NCAP, where they want full pedestrian detection so that there is much more safety on the roads to reduce any of these. We expect that the global ADAS market is going to triple to 83 million by 2030. And here I have some of the ADAS features that's being shown. And most of this you see when you go onto a showroom, you see these as the features that the cars have today. And these are all powered through sensing capabilities, whether be it camera, which is right on your windshield, you see them. There's radars, which is, you don't see them. It's very nicely hidden from the fascia on the cars. And then the LiDAR, some of them do have LiDARs as well, and we'll start seeing how the LiDARs are making into these passenger cars. It's very interesting how all of these market trends and the interest in automated driving has pushed forward the sensing technology and where it's going forward. Right? So we were just talking about passenger vehicles. So what about trucking? So when we talk about entire autonomous vehicles, one biggest factor is trucking. And trucking is about 3.7 million Class 8 trucks in just US alone. And with the pandemic hit, most of our goods are being transported through these trucks, as you probably are known towards. You see all of them on the roads also. And there's a huge demand for goods to be transported. and the rates are getting high. And you can see that some of these are going to be expected to grow 10%, reaching 88 billion by 2027. That's quite there here. So we expect this trucking market to push faster, taking all these sensing capabilities in and make it more automated. And what is driving this the most is the driver fatigue factor of it. Driving a truck is not like driving a car. It's like being in a rig. So we recently got a couple of feature updates from my FAE who's been working on one of our trucking customer. And he asked us to add a lot of shortcuts on the keyboard because he's driven at the back of this rig, and it's not easy to do any typing or selecting or any visualization things. It doesn't work. It's really tough to be sitting in that rig, and the fatigue cost to that is pretty high. And also with all the pandemic hit, in general, there is a huge shortage of drivers in the trucking market. But it's interesting that because of this demand and the sensing capabilities coming forward, we see many of the autonomous driving software companies like TuSimple having to show hub-to-hub automated driving. With, of course, they have, because of regulations, they have safety drivers there, but the truck drives on its own, and it's shown that from Arizona to Texas, and a few others like Idar showing middle mile logistics as well. And this is supposed to, the whole idea here is it'll slash the cost of the transport of goods. You will also see many of these also going electric because these are the key things that's happening in the future with automated driving and being electric for all the factors related to climate change as well. We all have heard about robotaxis. In 2017, there were a big boom of these robotaxis, and actually you'd still see them driving in SF and Mountain View with all of these sensors mounted on it. Where did they all go? What is happening to them? So with the quest with all of these sensing capabilities, everything, there's been big movement in terms of technology, but in many of the cases, the business models probably did not pan out, and you're starting to see them consolidate. And the way we are seeing it in terms of how the market is going forward, the OEMs are pushing forward with level 2+, up to 3 and beyond at this point of time, and that's growing faster, while the level 4 and all other players are taking it slow at this point, and that's going to come in the future. And many of these consolidation also has led to sharing of intelligence between the teams. So we saw Uber ATG getting bought into Aurora, and similarly Cruise to GM and et cetera. So that kind of also pushes forward the knowledge base as such. And the idea here is that at the point when the people like you and me start buying these level 2+ cars and gains more trust, the level 4 capabilities would be available, and we can start using it in a geo-fenced areas. So what about industrial applications? So it's just not in the passenger vehicles or commercial vehicles LiDARs are used. It's becoming more utilized in intelligent traffic light systems, mining, autonomous forklifting, all of these spaces because of multiple factors and also the advancements in technology as such. And in total, it's going to be about 2.7 billion in 2022 in terms both in automotive as well as industrial all put together. And that's a 19% increase in use of just LiDAR in this space. All right, so till now, you saw how the market and also the interest is pushing forward for having sensors on the car. And what are these sensors we are talking about? We saw a lot of features, levels of automation. What makes it really happen? And these are generally enabled by 3 main sensors, the camera, the LiDAR, and the radar. And you will see more of radars and cameras on the roads today. And each one of them provides unique features. Radars give measurements, but there is a lack of resolution it adds. And camera also gives you a lot of information, but it doesn't work at night and weather conditions. That's why having a complementary set of sensing for fusion enables autonomous driving vehicles, or just in general, any safety features to work better, whether it be day, night, rain, snow, etc. So that's why having a LiDAR has been starting to see lights in L2 plus and beyond capabilities. Because of its precise measurements and precise measurement data, as well as having few other key factors into working at night and heavy rain conditions when either one of the sensing is down. And in general, these are talking about today's sensors. But what do we need to get to level 3, level 4, and level 5? Can just the basic sensing capabilities work? And is that enough? That's when we start thinking about having sensors which are much more intelligent in them. Having sensors just that works like our eyes, human eyes, where it takes the interaction from the human brain. It's like an AI for us, right? Where it takes auditory cues, for example, from ears or from our skin, and then uses that to judge what is going to be a threat and take the necessary action. And your eyes goes with it. For example, you have seen on the roads, when you're driving, your eyes are fixated in the horizon, specifically highways. And if you hear a siren, your ears hear it, you don't see it. And then you immediately move your eye from the horizon to the side mirror to see there's something coming from the back. This is exactly what our sensors of the future should be able to do to get to level 4 and level 5 for those last 90 to 100% of those unique use cases, tough use cases. And when I say that, let me elaborate a little bit more. For us to take a fast reaction in a generic sensing capability, we first observe what's happening, then we try to understand, okay, that's a pedestrian, that's a car, try to understand that feature extraction, then decide, is there a threat? Is there something, a deer that's fast running that I need to stop the car or not? And do I have enough, in certain cases, you may not have enough information. Then you have to repeat this whole cycle and then figure out whether you should really do a brake or not. Now, all of this being done within hardware and trying to understand all this happening can take multiple seconds to come to a reaction time. For getting to level 3 and beyond, we need to reduce this reaction time so that we can efficiently make the right decision faster. And all of this, we have a limited power budget, limited bandwidth. We can't throw in a lot of data as well. We have to do it all real time. All of these factors kind of contribute to having more intelligent sensing capabilities within these autonomous driving vehicles. Let me show you by an example here in this video. Can we have the video on? Let me explain to you what's happening here. So if the video doesn't come up, what it's going to show is how generally our current sensors scan. Like it's scanning from top to down. You can also think of it as camera pixel reading from the top to down, raster scanning it. And then it's giving so much importance to all the data. But if you look at the scene, so much of it is sky. So much of it is static wall over there. Do you need all of this information when you're driving? So what is more pertinent is that those cars driving there, the pedestrian and the bicyclist, what you see here is very uniform scan pattern, trying to do everything. Then think of this scan pattern, where you're trying to get the most pertinent information. And that is good enough to get you the most important features out of the scene. Now think of a case where our sensing capabilities can do this today. At AEye, we are thinking about this whole design, about mimicking the way humans think and using the biomimicry into our design. So we kind of generally define this similar to the levels of automation. We're just splitting how the sensing should be into 4 levels. The first level is Idar design. That's like our standard sensing capability. It just works, we set it up once we start the design. It repeats that throughout the life, maybe 10 years, 15 years. The next level, we call it the triggered Idar, where the sensor has multiple ways of working. That is, it works in a specific way when it's on a highway. It works differently in a different scene, like an urban scene, or if it's mounted on a pole which is 10 meters up high, how it will behave is different. So that we can trigger it based on GPS, IMU, or even through the perception engine through which it's being driven. The next level is called the responsive Idar. And the responsive Idar is much more intelligent than the triggered Idar, where it's doing it on its own. You have AI within the sensor where it's using all of the information. It is feature extracted, and it's probably looking for more information. So it can give cue back to the sensing capabilities and say, I need more information here. This is the region of interest. Can you bring more resolution back? That's a responsive Idar. And for the last level 4, level 5 scenes, as an example I told about the unprotected left turn, having predictive Idar. You're driving down the road, and there's a fast car coming down, and you have an unprotected left, and it's highway speeds. What would you do? It's not enough just to get the information from the straight ahead. There could be motorcyclists or cars coming from here. And predicting what's happening in the scene and trying to get the most important information there would make the huge difference by either having an accident or doing a safe left turn in these scenarios. So that's a final level of Idar. And just to give, that was all theory. Now let's see this in practice. So we have here Carson from Dublin. He's a senior field application engineer. He's right now on the car with the Foresight M product mounted on the car, and he's going to give us a demo. Hey, Carson.
Hi, Indu.
How are
Thank you
you?
so much for having me here today. It's a pleasure being here with everybody, being able to present AEye's software-definable LiDAR system to everybody here today. So before we get started in this LiDAR tour, I'm going to get everybody acquainted with the visualizer. So what we're looking at right here, each gray circle is 25 meters, and these blue circles are 100 meters. There are 3 blue circles for a total of 300 meters worth of range. And as we're driving, you'll see detections happen in this black area out here, all the way up from 300 meters all the way out to 1,000. So I'm going to zoom back in here. We're sitting in a Whole Foods parking lot in Dublin, California right now. And as we're static here, I'm going to take this opportunity to go through some of the things that really make AEye's LiDAR system unique. So because we have our small mirrors, our MEMS, our complex laser firing system, and our 1550 nanometer amplifiable wavelength, we're able to kind of define how we scan a scene in front of us based off of a customer's use case. So what I'm showing you here right now is a uniform type scan pattern. And when I sit in this inside view, you can see how we're getting a constant resolution across the field of view. This would be something an ADAS perception stack might prefer, maybe some type of various customer use cases in the driving or autonomous vehicle domain. I have a 3-zone uniform pattern, and when I switch to this pattern, you can see how we really focus our point budget on the horizon in front of us. So this scan pattern would be great for some type of urban environment where you want to be able to see maybe a bike on the road out in front of you. You also want to be agile enough or adaptive enough so that if something enters the scene nearby, you're able to take the correct course of action. Another scan pattern I'm going to show here is this long-range trucking scan pattern. You can see how we remove some of the near-field ground plane detection in preference to spread that points out even further at range. So this scan pattern would be great for picking up small objects out to 200 meters, vehicles out to 300 meters, and even signs and overhead passes out to 1,000 meters. The last scan pattern that I'm going to show you all today is another scan pattern I'm going to show you all today is the smart city scan pattern. Although this smart city scan pattern wasn't optimized to be on top of a car where the LiDAR is located now, this scan pattern was optimized to be mounted on top of an intersection for an intelligent traffic system type setting, or inside of a building for a security type application. The final scan pattern I will show you all today is the Idar scan pattern. So because we are able to define exactly how, where, and when we want to shoot, we can even schedule our LiDAR to spell the word Idar, intelligent detection and ranging, out into the scene in front of us. Indu, is there anything you'd like to add before we start driving here?
Absolutely. I have some slides to show on the left. You'll see it on the left and the right. What basically Carson is showing is a visualization tool where he is actually going and selecting different scan patterns. And what he's doing is, you can think of the autonomous vehicles using SDK or the perception engine to trigger each one of these scan patterns, as we call it, which kind of does different scanning methods based on the use cases. And this is possible because of a unique architecture and the ability to move faster in the scene and with full agility and through software definability. And this is all done in a single hardware. Carson, why don't you show the live demo right there?
Yep. So for the audience, we are about to merge on the highway here. We'll be merging onto 580 headed westbound right outside of Dublin, California. And one of the things I kind of want to take this time to mention is how we kind of design these scan patterns when we're thinking of a specific customer use case. So the three main trade-offs within AEye's LiDAR system is our range, our resolution, and our refresh rate. Current practices in the automotive market almost demand a 10 hertz refresh rate. So that's what we're showing you here today. And then it's kind of a trade-off between our resolution and the range. So you can see in this long range scan pattern how we're really emphasizing that we want long range detection. So we're able to see these cars as they're headed outward from 100 to 200, even 300 meters. And if you look, you'll see these overhead signs, these big retroreflectors coming in at far distances. And so this is AI basically saying, hey, we want to make sure that we're covering everything on the horizon out in front of us. If it's a long-range trucking type application, we want to make sure that there's no small objects that get by us. And we also want to be able to then trigger based off the environment around us. So these scan patterns could be triggered based off anything from an IMU, the speed of the vehicle, maybe the angle of the steering wheel, or even potentially a GPS type system. So now we're merging off the highway here, and you're able to see how we're seeing still the ongoing traffic, yet the direction and flow of the road as we make our exit off of the highway. So this was an example of type of how we're able to software define using our laser system exactly what we want to scan. As we're kind of coming to a stop here, I'm getting ready to show you all a video versus our triggered and responsive Idar. But before I show that video, I'd like to ask Indu if there's something she wants to make a statement here about.
Sure. So we saw here how the car drove through the highway and how you're getting long-range detection using the triggered scan patterns. Next, Carson will also show about responsive Idar capability. This is where we're having more intelligence into the sensor as such, where the sensor is deciding what should I be adding more on to the scene. So you can think of the biomimicry thing, which I just mentioned before, and you will start seeing that in this video, where it's searching for something and adding more points to it. And the main idea here is to be situationally aware and using the AI feedback loop, whether be it within the sensor or external to the sensor, and then scan the entire scene or environment around you with more clear information. All right, Carson, let's look at what you have.
Thank you, Indu. So just as a brief note before we begin this video, you'll see we are scanning a section of pedestrians getting ready to go to a football game. These orange points that you see on the screen are the background scan pattern, and then you'll see these magenta points pop in. Those magenta points are objects or things of interest to us so that we're specifically engaging onto and further inquiring for more information. As you see here, this is the side view of the overall scan pattern that we're shooting. and it'll turn magenta, highlighting the objects and areas of interest to us in the scan pattern, letting us be aware of anything that we need to see, and really increasing our confidence of detection. And so with the conclusion of that video, that's all I had prepared for the demo today, and I'll pass it back to Indu. Thank you so much for having me on here, and it was a pleasure speaking with everybody.
Thank you, Carson. Thank you for such a lovely demo. So I hope you liked the demo and how it was all done in a vehicle with just one single sensor. As I showed you a few slides back, there's multiple sensors being mounted on autonomous vehicles. And you will start seeing that your smart cities and the infrastructure around you is getting smarter with having more sensors, ability to communicate to each other, and making the entire space safer, getting more information out. What does this mean for sensors? Can just a regular sensor that we have today work, or do we need sensors that take the cue from the traffic post there's a pedestrian that's coming by, or there's an ambulance that's coming by, be aware, and take the right necessary action. That kind of smart intelligence built into sensors would enable these kind of smart cities. You've probably seen these smart cities. Michigan has one, and also Florida is coming up with these smart cities. These kind of smart cities allows you to make the autonomous driving features much safer and to bring out those level 3 and beyond onto our roads faster as we want it. You can also think about this as each one of these cars, your phones, all of these are nodes in the network that's collecting a lot of data. And this data is being used to either provide you better software updates, and over a period of time, you will get much better capabilities. Like you want something you start with might be buggy, and then you get a better update on it. As you've all seen, 3-4 months or 6 months is generally the time period for seeing these kind of software updates coming in to your phones. Cars might be longer, but Tesla has already adopted this, as you've seen. So what does this mean, right? We have software updates coming in. Now think about when we can do something similar with hardware. Think about when we can have products which are modular and can have these kind of hardware updates, maybe not 6 months, maybe 1 year. This is something I would like all of you to think about, and if you have any comments, reach back out to me, and I'm happy to discuss this with you all. With that, I would like to thank all of you for coming here and being such a lovely audience. It's really a pleasure to be in person, and thank you, Informa. Thank you, Jen, and everybody here for being in this keynote. If you have any questions, please reach out to me. My email is ivijayan@aeye.ai. Thank you, everyone.
Thank you very much, and please thank Carson for us. That was
Absolutely.
An amazing demonstration. I really enjoyed it.
Thank you, Naomi. It was a pleasure.